Hello everyone. So on this video I'm going to give you an introduction to the first topic. So the first topic is basically a review of probability and statistics, and it's a kind of review of your prerequisite, whether the prerequisite is the foundation of econometrics, which is econometrics 1, or the introduction to statistics. So, um, before we start, just the definition of what is econometrics. Econometrics is basically economic applications using data sets. You can think of it as part of the word is economics, and metrics is like the quantitative part or measuring. In other words, measuring economics, measuring the economic theory, or using data set in order to ensure that the prediction of economic theory is matching what we see in reality. And what we see in reality depends on the data set. So you can think of econometrics as a mathematical way to quantify how a change in one variable affects another variable, holding everything else constant. So, the world is very complicated, right? So we have so many variables working together or moving together. So we have every time to think about it this way. We are focusing on one variable affecting another variable, right? Holding all other variables constant. So, for example, if I think about gross domestic product, and from my macro course, we know that it is a function of so many variables, right? It's affected by inflation, it's affected by investment, it's affected by consumption. It has so many variables affecting it. So let's just list two of them. So we know that it's a function of investment, right? We know it's a function of inflation. I'm just going to write the first three letters, and other variables, right? So we have so many other variables. If I just focus on these two, then a mathematical way of writing it would be like, okay, GDP is equal to a certain constant, right? Let's call this constant as a Latin letter, let's say alpha 0, plus a certain slope alpha 1 investment, plus a third slope, a second slope alpha 2 inflation, right? Plus we can call it other factors that we will study later. And if I'm talking about this variable over time, right? So if I'm talking about GDP, and this is the time, and this is GDP, and this is 1990, and this is, let's say, 2000, and this is, let's say, 2010, or anything, right? So it's kind of moving, changing over time. Probably I have a recession, it comes back up, and then and so on. And it also has a certain average or a trend, okay? The same for inflation. I can have also a graph for inflation, right? And then I have inflation coming up and down and so on, and the same for investment and so on. So if this is the time, let's call it T. If this is the time, let's call it T. Then I have to have a sub T under each variable here to notify the reader that we understand that this is a variable and this variable is moving over time. So we said that this is kind of called the intercept of the relationship or the constant, right? This is a slope. You know, the slope is the change in GDP because of the change in investment. This is another slope, right? The alpha 2. Then it's the change in GDP because of the change in inflation and so on. So the idea of econometrics is we try to quantify this relationship. So number one, I'm trying to quantify the impact of investment on GDP holding inflation constant, right? And then my other objective would be quantify the impact of inflation on GDP holding investment constant, right? So each one time I'm focusing on one direction or one relationship, holding the other relationship constant so that we can get a quantifiable answer. Okay, so basically econometrics is all about measuring this relationship. So by the end of the day, I'm going to have a number for alpha 1, I'm going to have a certain number for alpha 2, I'm going to have a certain number for the intercept. And when I say a certain number, we call it an estimation. So I'm trying to estimate. Whenever I say estimate, then I add a hat here, so that I kind of differentiated from the actual. So hat here stands for my estimation, which could be very close to the actual impact or could be far away, and I'm making like so many mistakes and I do have to repeat the model all over again to get a closer estimators, right? So the idea would be by the end something like, okay, I want to make sure that my quantifiable slope, let's say alpha 1, is very close to the true alpha 1, okay, which probably I don't know. And I want to also make sure that my slope, my quantifiable slope for alpha 2 is very close to the true alpha 2. And the same for the slope. My estimation for the slope is very close to the actual slope. So you try to get estimators, you call these estimators, or you call them sample estimators, and you call these the actual one, or in statistics we call them population parameters, right? So here you're trying to estimate the parameters of the population. Let me give you an example. Let's say you were looking at students graduated from Rutgers, Camden with a degree in economics, and this big population of students, let's assume over the last, for example, 10 years, maybe, I'm just saying a number, okay, 500 students. Okay, so I have 500 students, so my population, I'm gonna call it P, my population is 500 dots, right? Students. I'm gonna ask each student how much you earned, okay, in your first job. Probably I will not be able to reach out to the 500 students, but I can take a sample from this big population, and hopefully this sample, I'm gonna call it S, of just a small portion, right? So let's say 50 students. I can reach to 50 students, and I actually can ask them how much you earn, right, on how much did you earn on your first job. Out of their responses, I'm gonna get an average. So let me call this average as Y bar. So Y bar is their answer to how much they earn in terms of a salary, right, on their first job. So let's take an example, and their average of responses is 45K. They earned 45,000 on their first job. Okay, I have no idea about those students because it's a big population, it's a big number, so I don't know, I can't reach to them, but maybe on Google I can get a number, okay, and I can consider this as my population unknown parameter. So I go to Google and I search how much students with economics degree will earn, and probably Google would give me an answer saying that this number, we call it mu, which is the population mean, the population mean of those students, probably 50K. Okay, so by the end of the day, you will have something like this. Y bar is my sample mean, mu y is my population mean. You want this sample mean to be as close as possible to this population mean. So this is the population mean, we call it mu y. This is the sample mean, we call it Y bar. You want these two to be as close as possible. So in other words, I gave you just an example with certain numbers, and I said, okay, this is 45K, and the gap is 5K, right? Because from Google, we think that those are supposed to be 50K, so I'm talking about there is a gap of 5K. Can I get another sample of another 50 students and ask them how much you get? Probably those who are going to tell me 48K. Can I repeat it again? I get another 50 students and ask them how much you earn? Probably it's even worse, 44K. So the gap is even bigger than 50. So the gap here is 6. The gap here is going to be 2. So this is the best, right, estimator out of the 3. If I call this y bar 1, I call this y bar 2, which is my second trial of getting another 50. This is my third trial of getting another 50. Out of the y1, y bar 2, y bar 3, I think that y bar 2 is the best estimator because it's the closest to the population mean, because the gap is only 2, right? So you can think of it this way, that you want to try to minimize the gap, right? The gap between between y bar, which is the sample mean, and mu y. If I repeat this experiment multiple times, I want this to happen to be as close as possible to the population mean with a very high probability. P here stands for a very high probability. In other words, let's say there is it's very, very close to the population mean with a probability that is 90%, for example, or above. So it's very, very close. Okay? So this is just a brief idea of what we're doing. Every time we're trying to estimate a model, right? So now I said GDP and investment. So I'm going to have GDP is a function of, or it has a certain intercept. Let me call it beta naught. Doesn't have to be alpha, could be beta, could be gamma, could be lambda, could be anything. Okay, beta naught plus beta 1, investment plus beta 2, inflation plus other. Okay, and in econometrics we call this other as error term. So let me write it for you as an error term, because I might be doing a certain mistake. It might be something that I intentionally didn't include in my model, and so on. So let me call this one as U, where U stands for the error term. And we agreed that this is moving over time, so I'm going to have a sub t everywhere, even in the error term. Okay? So this could be, we can call this the actual model, okay, or the population model. I want to estimate this, so I'm going to get data set, and I'm going to use a software to get estimators, right? So I'm going to have estimators for these parameters, okay, and again, these variables are over time, and I want to make sure that this estimated GDP is as close as possible to the actual GDP. In other words, I want to make sure that my estimated GDP is very close to the actual GDP. And for this to happen, then the components of the two equations have to be very close. In other words, I want to make sure that beta hat naught is very close to beta naught, beta hat 1 is very close to beta 1, beta hat 2 is very close to beta 2, so that I can minimize this error as much as possible. So you want to minimize the error in your estimation as much as possible by making your estimator very, very close to the true or the actual population variable. Okay? So in order to do that in econometrics, we have to be based on a certain theory, and that's why prerequisites for this course is macro or micro, right? So it's not or, I should say and, because every time I am trying to formulate a model, it has to have some basis, right? Because I can always get the data for anything, okay, for price of banana in, for example, Brazil, as a function of my age. If I take my age, okay, or a group of students, okay, cross-sectional, for example, data set, and I try to find a relationship between these two, right? Then I can find a certain important relationship. As I grow older, the price of bananas in Brazil is increasing, and I can also graph it and say, okay, this is my age. As I grow older, the price also increase, and I can say, oh, there is a very important relationship, right? So in order to avoid these nonsense models, we have to base our models on economic theory, micro or macro. So the example I gave you before was a macro model, but I can also think about firm profits. So firms profit, so this is the pie for profits, okay, over time is a function of an intercept plus how much they charge in terms of price for their goods, right? Plus, let's say, whether they pay in promotion for their products. So promotion or advertising is an important, plus other factors, we call it error term or UT. Okay, so something like this is based on economic theory. Based on economic theory, I know that there is, as the price increases, the firm would make more profits. So I'm expecting this sign to be positive, right? As the firm is making more promotion, then I expect firm's profit to increase. So I'm expecting the sign to be positive, right? And also has an important magnitude, and price also has an important magnitude. Okay, so every time in this course or in econometrics in general, when you try to measure a certain model, you have to make sure that it's coming or it's based on a certain theoretical model. Okay, and that's why important papers would always start by referring to the model that they trying to estimate, let's say the Phillips curve, okay? So the Phillips curve, okay, there is a relationship between GDP and unemployment. So they would start by discussing the theory, and then they would gather the data on unemployment and GDP and try to find whether the predictions of the Phillips curve are proven in the data set. Okay, why we're doing that? Because we want to avoid any nonsense models. We have to be based on economic theory. Okay, so whatever we're doing in econometrics is just a mathematical way to quantify the change in one variable, how this change in one variable is affecting another variable. In the first topic, we talk about different ways of getting data. Okay, so we have basically two sources of data. Okay, so data can be coming from experiments, right? And then it can be observation. So experiments are not widely used in economics. Okay, so mostly in like the medical field or in chemistry or in biology, right? They perform experiments. Okay. We don't do experiments in economics, right? So if I want to check what is the impact of increasing taxes on cigarettes, on the consumption of cigarettes, I cannot get people and ask and perform the experiment on them and see them how they are affected by cigarettes, for example, right? If I want to see how students are affected, or the enrollment in at Rutgers is affected by the increase in tuition, I cannot increase the tuition and check how students are responding. Okay, so at many times it's not possible or it's unethical to perform experiments, and that's why those are basically not performed in economics. We depend more on observational data. So what is observational data? These are data that are collected by surveys, by telephone, right? So when you perform a survey after you buy something online, this is observation. Economic data are obtained by observing how the real world behave, how inflation is responding to the increase in interest rate, right? How investment is affected by the increase in interest rates, how GDP is affected by the multiplier. All of these are called observational data. So our course is mainly focusing on observational data, and we are not using experimental data. Okay. The other thing that we discussed on the first chapter, which is the different types of data. So we have, so those are two sources, but we have three types of data. So the three types of data, we have cross-sectional. I'm sorry, the iPad is very slippery, so my handwriting is not that bad in reality. So, and this is time series, right? And then this is panel data. So we have three types of data: cross-sectional data, time series data, and panel data. So the cross-sectional data, as the name suggests, you are talking about multiple entities. So these entities could be countries, could be students, could be governments, could be what else? Households, right? Could be different cities in a certain point in time. So cross-sectional data would be something like student 1, student 2, student 3, all the way student 10, and I'm checking their grades in a certain point in time, which is, for example, their average grade in a certain assignment or a group of, let's say I'm taking the spring semester, so I'm just taking the average of 5 assignments for student 1, the average of 5 assignments for student 2, the average of 5 assignments. So each one has just one number, okay? So this person, the average out of 20, he got 18 or she got 18. This person got 15 out of 20. This person got probably 17. This person got 20 out of 20, okay? So this is performed in a specific point in time, which is the spring of, let's say, 2021. So in 2021 is a certain point in time, and I'm moving over different cross sections, different students. You can think also in another example. Let's say I'm doing an analysis on Latin American countries or selected Latin American countries. So let's say I'm talking about Argentina, Brazil, Chile, Peru, and I'm checking their GDP in a certain point in time in the 1990. So I have a certain number here, certain number here, certain number, certain number. So I'm looking at the GDP at a certain point in time, which is a specific year. So I'm moving through cross sections here, countries. I'm moving through cross sections here, students. Okay, so this is cross-sectional data where we are fixing the time, or we are observing data of multiple entities at a single time period. The opposite to that is the time series. So in the time series, you have actually a single entity, right? I have a single entity, and this single entity is observed over time. Okay, so I have, let's say, one student. Let me call the student, let's say, Alex, or student 1, and I'm looking at the grades or scores, okay, for this assignment, for the student over the weeks. So I have week 1, this person got 18 out of 20. Week 2, he or she got, let's say, 15 out of 20. Week 3, he got 13 out of 20, and so on. Week 14 towards the end of the semester, 19, for example, out of 20. So what we're doing here is we are observing the grade over time. Okay, so the time here is weeks, and here I have grade or the score. I should say score, but anyway, you understand the idea. So the grade here would be like some numbers, and the maximum is 20, and then I would be like, okay, this is week 1, this is week 2, all the way 3, 4, and until week 14, and then okay, we start by 18 somewhere here, 15 here, 13, and then probably something like that, and then 19 up to here, and then I can get. So this is called time series data. If you want to think about it in terms of the example of countries, then again, I'm talking about Argentina. Just choose one country, okay? Here I chose one student. Another example, I choose, let's say, Argentina. So I'm observing GDP in Argentina over time from the 1992, let's say 2022. Okay, and the graph for Argentina would be here the year, and we start from the 1990 and all the way until 2022. This is GDP in dollars or in billions of dollars, and then the numbers here, and then again something like this over time. Okay, so again, time series consists of single entity observed at multiple periods. Finally, when you combine cross-section with time series, you get panel model. So, panel data. So panel data is just a combination of the two. Okay, so it consists of multiple entities observed over 2 or more time periods, or observed over multiple points in time. So let's say you're talking about student 1, okay, for week 1, week 2, all the way up to week 14, okay, and this is the grade. All right, and then I have a grade, we said for the example, we said the first one was 18, 15, 13, so 18, 15, 13, the last one was 19, and then I will go to student number 2, and then I have week 1, week 2, all the way week 14. I have the grades for student 2. I go for student 3, week 1, week 2, all the way to week 14, and you keep going, right? So this is a panel data. Panel data consists of multiple entities, student 1, 2, 3, 4, all the way up to student number whatever, observed over multiple time periods. Also, when you take the example of the countries, Argentina, so Argentina starting from 1990, 1991, let's say I have 3 time periods, okay, 92, and this is GDP, and then the number here, the number here, the number here, and then Brazil, and then 1990, 1991, 1992, I have the numbers here, and then I go for the next, Chile, then a 1990, I think you get what I mean now, right? So it's 1992, and then you have the data. So panel data is the best kind of data because, as you know, you actually want to get as much information as possible, right? When I talk about cross-sectional data, then I'm just talking about a group of students in a single point in time. When I talk about time series, then I'm just talking about one student over time. Panel is the best because you're combining time with cross-section, you're getting so many information that can help you to get the best predictions ever, that can help you to get the closest, you go back to our point, that can help you to get the closest estimator, right? You want your predictions, your estimators to be as close as possible to the population parameters, okay? So this is what we're doing in this course. We're basically trying to find a mathematical way to quantify the relationships between different variables using different types of data sets. We are using basically observational data set. We will be using cross-sectional in most of the course. Towards the end, we will be using time series, and we will have a topic on panel data. Advanced courses in econometrics with focus on time series data. You will be doing forecasting models and so on. Okay, so I want you to read for these slides. I want you to read chapter 1. It's very much related to what I just discussed with you.